NENOMATICA, where mathematics meets YouTube excellence. The addition and subtraction of powers. Today we'll be solving two different problems involving exponents and powers of the same base. Let's start with our first example. We want to find the value of the expression 8 to the power of negative 60 plus 8 to the power of negative 61 divided by 8 to the power of negative 60 plus 8 to the power of negative 59. Let's begin by factoring out common terms. In the numerator, we can factor out 8 to the power of negative 61 from both terms. We get 8 times 8 to the power of negative 61 plus 8 to the power of negative 61, which equals 8 to the power of negative 60 plus 8 to the power of negative 61. Now, using the power rule, we know that 8 times 8 to the power of negative 61 equals 8 to the power of negative 60. So our numerator becomes 8 to the power of negative 60 plus 8 to the power of negative 61. Let's factor the numerator. We can pull out 8 to the power of negative 61. This gives us 8 to the power of negative 61 times the quantity 8 plus 1. The sum inside the parentheses is 9, so we get 8 to the power of negative 61 times 9 in the numerator. Similarly, for the denominator, we can factor out 8 to the power of negative 60. This gives us 8 to the power of negative 60 times the quantity 1 plus 8. The sum in the denominator's parentheses is 9, so we have 8 to the power of negative 60 times 9. Now, we can cancel the factor of 9 from both the numerator and denominator. Using the property of exponents for division, we can subtract the exponents. We get 8 to the power of negative 61 minus negative 60. Negative 61 minus negative 60 is the same as negative 61 plus 60, which equals negative 1. Now, we can rewrite 8 as 2 cubed. When we have a power raised to another power, we multiply the exponents. So 2 cubed raised to the power of negative 1 equals 2 to the power of 3 times negative 1, which is 2 to the power of negative 3. Now, let's move to our second example. We want to evaluate the expression 4 to the power of 1000 plus 16 to the power of 500 plus 64 to the power of 100 times 2 to the power of 1400 plus 2 to the power of 2000. For this problem, we'll start by expressing all terms as powers of 2. First, 4 equals 2 squared, 16 equals 2 to the 4th power, and 64 equals 2 to the 6th power. Now, we apply the power to a power rule. When we have a power raised to another power, we multiply the exponents. So 2 squared to the 1000 equals 2 to the power of 2 times 1000, which is 2 to the power of 2000. Similarly, 2 to the 4th power raised to the 500 equals 2 to the power of 4 times 500, which is 2 to the power of 2000. And 2 to the 6th power raised to the 100 equals 2 to the power of 6 times 100, which is 2 to the power of 600. Using the product rule for exponents, 2 to the power of 600 times 2 to the power of 1400 equals 2 to the power of 600 plus 1400, which is 2 to the power of 2000. Now, we have 4 terms of 2 to the power of 2000. We can factor out 2 to the power of 2000 from all terms. The sum inside the parentheses is 4. We can rewrite 4 as 2 squared. Using the product rule again, we get 2 to the power of 2 plus 2000, which is 2 to the power of 2002. In this video, we've seen 2 examples of solving exponential equations. The key techniques we used were factoring out common terms, using properties of exponents, rewriting expressions with a common base. These strategies help us to simplify complex expressions and find their values efficiently. We need to evaluate the expression 3 times 3 squared plus 3 cubed plus 3 cubed. First, let's apply the exponent rules. We rewrite the expression as 3 to the power of 1 plus 2 plus 3 cubed plus 3 cubed. This is because when we multiply 3 by 3 squared, we get 3 to the power of 1 plus 2 according to the product of powers rule. Now we can simplify 3 to the power of 1 plus 2. This gives us 3 cubed plus 3 cubed plus 3 cubed. Now we can factor out 3 cubed. This gives us 3 times 3 cubed. Finally, we apply the product of powers rule again to get the final answer. 3 times 3 cubed is 3 to the power of 1 plus 3, which equals 3 to the power of 4 or 81. This one is more complex and involves fractions and multiple steps. Let's solve this step by step. First, we'll evaluate all the exponents in the expression. In the numerator, 2 to the power of 4 is 16, and 4 squared is 16. In the denominator, 6 squared is 36. Now, we'll multiply the terms in the numerator and denominator. In the numerator, 1 over 16 times 3 times 16 simplifies to 3. And in the denominator, 1 over 3 times 36 equals 12. Let's continue simplifying. 1 minus 3 is negative 2. 2 minus 12 is negative 10. Finally, we can simplify the fraction. Negative 2 over negative 10 simplifies to 1/5. And that concludes our examples of evaluating algebraic expressions. Remember to work step by step, simplify expressions whenever possible, and always check your final answers. I hope this lesson helped you understand how to approach these types of problems. Welcome to our math tutorial. Today, we're going to solve a problem involving simplifying exponential fractions. Let's look at our example. We need to find the value of the following fraction: 4 to the power of 25 plus 2 to the power of 48, divided by 4 to the power of 24 plus 2 to the power of 46. Let's start by rewriting 4 as 2 squared. This will help us work with a common base. Now, we'll apply the power of a power rule to simplify the expressions in the numerator and denominator. When we have the power of a power, we multiply the exponents. Next, we can factor out the common factor 2 to the power of 48 in the numerator and 2 to the power of 46 in the denominator. Let's calculate 2 squared plus 1. 2 squared is 4, so we get 4 plus 1, which equals 5. Now, we have 5 times 2 to the power of 48 in the numerator and 5 times 2 to the power of 46 in the denominator. Now, we can simplify the fraction. The 5 in the numerator and denominator cancel out. We're left with 2 to the power of 48 divided by 2 to the power of 46. Using the division property of exponents, we can rewrite this as 2 to the power of 48 minus 46. Finally, 48 minus 46 equals 2. So our answer is 2 to the power of 2, which is 4. So we've solved the problem by rewriting all terms with a common base, factoring out common factors, and then simplifying the exponents. The answer is 4. This approach can be used for many similar problems involving exponential expressions. Welcome to this mathematical tutorial, where we'll prove the equality of two exponential expressions. We'll see how to manipulate exponential expressions and use properties of exponents to verify given equalities. Let's start with our first example. We need to prove that the following equality is true. First, let's manipulate the numerator and denominator to identify common factors. In the numerator, we can rewrite 2 to the power of 30 as 2 to the power of 28 multiplied by 2 squared. Similarly, in the denominator, we can express 2 to the power of 20 as 2 to the power of 18 multiplied by 2 squared. Now, let's factor out the common terms in both the numerator and denominator. From the numerator, we can factor out 2 to the power of 28. Let's calculate the values inside the parentheses. 1 plus 2 squared equals 1 plus 4, which is 5. The 5's in the numerator and denominator cancel out, leaving us with a ratio of powers of 2. When dividing powers with the same base, we subtract the exponents. So 2 to the power of 28 divided by 2 to the power of 18 equals 2 to the power of 28 minus 18. Computing 28 minus 18 gives us 10. So our result is 2 to the power of 10, which matches the right side of our original equation. This confirms that the equality is true. Now, let's move on to our second example, which is more complex. We need to prove that the following equality is true. Let's rewrite this expression using the properties of exponents. First, let's note that 25 equals 5 squared, so we can rewrite 25 to the power of x as 5 to the power of 2x. Now, let's use the product of powers property to combine the exponents. 5 to the power of 2x times 5 to the power of 1 equals 5 to the power of 2x plus 1. We also rewrite 25 to the power of x plus 1 as 25 to the power of x times 25 to the power of 1. And 5 to the power of 2x times 5 squared equals 5 to the power of 2x plus 2. Again, since 25 equals 5 squared, we can rewrite 25 to the power of 1 as 5 squared. So 25 to the power of x times 25 equals 25 to the power of x times 5 squared, which is equal to 5 to the power of 2x times 5 squared, or 5 to the power of 2x plus 2. Now, let's factor out 25 to the power of x from all terms. Simplifying inside the parentheses, we have 1 plus 5 to the power of 7 minus 100 plus 100 minus 1. The 100 and negative 100 cancel out, and the 1 and negative 1 also cancel out, leaving us with only 5 to the power of 7. Now, we rewrite 25 to the power of x as 5 to the power of 2x. Using the power to a power property, 5 squared to the power of x equals 5 to the power of 2x. Finally, using the product of powers property, 5 to the power of 7 times 5 to the power of 2x equals 5 to the power of 7 plus 2x, which is 5 to the power of 2x plus 7. We need to simplify and solve this complex expression. Let's begin solving this step by step. First, we'll rewrite certain terms using the properties of exponents. Notice that 3 to the x plus 1 is equivalent to 3 to the x times 3. Similarly, 3 to the x plus 2 is equal to 3 to the x times 3 squared. Now, let's focus on the denominator. We can combine all the exponents of 3. Remember that when we multiply powers with the same base, we add the exponents. This gives us 3 to the 1 plus x minus 1 plus x plus 2 minus x plus 3 to the x plus 1 term. Now, we'll work on the numerator. We can factor out 3 to the x from each term. This gives us 3 to the x times the quantity 1 plus 4 plus 3 minus 15 plus 9. Let's simplify the expression inside the parentheses in the numerator. 1 plus 4 plus 3 minus 15 plus 9 equals 2. Now, let's work on the denominator. We have 3 to the x plus 2 plus 3 to the x times 3. We can rewrite 3 to the x plus 2 as 3 to the x times 3 squared, and simplify further. We can factor out 3 to the x from the denominator as well. This gives us 3 to the x times the quantity 9 plus 3. Let's simplify the expression inside the parentheses in the denominator. 9 plus 3 equals 12. Now, the 3 to the x terms in both numerator and denominator cancel out. So our equation becomes 2 divided by 12 equals 1/6. Let's simplify our fraction. 2 divided by 12 equals 1/6, which matches the right side of our equation. So, our solution is correct. Let's try another example. This time, we have an equation with a different base. Let's use the same properties of exponents to simplify this equation. First, we'll rewrite terms like 2 to the x plus 2 as 2 to the x times 2 squared. Now, we'll factor out 2 to the x from each term in the numerator. This gives us 2 to the x times the quantity 4 plus 16 minus 8 plus 5. Let's simplify the expression inside the parentheses in the numerator. 4 plus 16 minus 8 plus 5 equals 17. Similarly, we'll factor out 2 to the x from each term in the denominator. This gives us 2 to the x times the quantity 3 minus 2 plus 16 minus 10. Let's simplify the expression inside the parentheses in the denominator. 3 minus 2 plus 16 minus 10 equals 7. The 2 to the x terms in both numerator and denominator cancel out. So our equation becomes 17 divided by 7 equals 17/7, which is the right-hand side of our original equation. So our solution checks out. In both examples, we used key properties of exponents to simplify complex expressions. Remember these important steps. First, rewrite terms using the properties of exponents. Then, factor out common terms from both numerator and denominator. Simplify the expressions inside parentheses. Cancel common factors. Finally, verify your solution. With practice, you'll become more comfortable solving these types of equations. 2 to the x plus 2 to the x plus 1 plus 2 to the x plus 2 plus 2 to the x plus 3 divided by 4 times 2 to the x plus 3 minus 2 times 2 to the x plus 3 minus 2 to the x plus 2 equals 5/4. Let's start by rewriting the powers of 2 using the property that 2 to the x plus n equals 2 to the x times 2 to the n. This will make it easier to factor out common terms. Now, let's calculate each power of 2. 2 to the 1 is 2, 2 to the 2 is 4, and 2 to the 3 is 8. I notice that 2 to the x is a common factor in both the numerator and denominator. Let's factor it out to simplify the expression. Now let's simplify inside the parentheses. In the numerator, we add up 1 plus 2 plus 4 plus 8, which gives us 15. In the denominator, we have 4 times 8 equals 32, minus 2 times 8, which is 16, minus 4, giving us 12. Since 2 to the x appears in both numerator and denominator, we can cancel it out. Finally, let's simplify the fraction 15 over 12. Both are divisible by 3, giving us 5 over 4, which matches our target value. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.